Hello, my name is Hannah and I'm going to talk to you today about our rockets kit and our clinometer kit. Now these two kits work really well together and you can do a lot of experimentation and formal investigations or even more complex investigations where you're doing bivariate data graphing, doing statistical analyses. You can do a lot more complex things, even all the way up to trig, using the conjunction of these two kits. Now the rockets kit includes enough to do 6 complete rockets, and we have 2 different designs for each. And you can use these to discuss different variables. Additionally, you can also see that we have the ability to do different heights with this because we build the body of the rocket actually out of paper. In elementary, it's really good for understanding non-contact forces, discuss gravity, why do the rockets return back to the Earth, which one went farther, which one went less far. If you adjust the angle of launch from this to this, will the rockets fly farther? They can start doing those basic introductory level experiments, and then as you progress into middle school and high school, you can just start doing measuring. You can collect the data, you can analyze the data. At middle school, you might mean an absolute deviation. At high school, you can do standard deviation. Beyond that, in middle school, you can also do two-way frequency tables, set a distance, figure out how many went more than or less than, so it's good practice on ratios. And then a lot of just bivariate data. So look at all the different variables, adjust them, see how it affects. Then in high school, you can start talking about the parabolic curve that the rocket follows. You can talk about quadratic equations, figure out the altitude of the rocket at various points. And to do that, you would use some of the features of our clinometer kit, where we have different options to build an altimeter, as well as to know the angle of launch. So you're using trig to determine the tangent lines. So now that you have a basic idea of how you would use this at any of the levels, let's talk about how you assemble it. For the rockets kit, collect a piece of paper. Then you need to get some 1/2-inch PVC pipe. Roll it around the PVC pipe. Make sure the paper is rolled tightly, and then take your selected tail fin with the bottom of the fins first and slide it all the way down to the bottom of your paper. And slide the nose cone of your choice over the top as well. You can then release the paper enough to let it be loose so that it goes all the way out to the same diameter as the inside of the rockets. Next, take tape and run tape the full length of the seam of your paper, as well as around both the tail fin and nose cone connection. Be sure to push the tape down against the PVC pipe so that it's a really solid connection. This needs to be an airtight seal. The rocket should now be able to pull smoothly out of the PVC pipe, and you're ready to go. To assemble your rocket launcher, you need about 2 2-foot lengths of 1/2-inch PVC, 2 90-degree angles, and 1 shorter piece. Secure the 90-degree corners of the PVC, 1 to each piece, and then combine them with the shorter piece. These are stomp rockets. Depending on the bottle you use, you might need to wrap a little bit of painter's tape around the end of one of your pieces of PVC. That way you get a really tight, solid connection when you slide the bottle onto the end of the launcher. You can use 16-ounce bottles, 12-ounce bottles, or even 2 liters. So it's really up to you to decide how far you want to make the students measure. That's how you set it up, and then you simply rotate it around to where you can set your angle here and adjust it. And then if you're doing it on grass, which is what we suggest in order for the rockets to survive a little bit better, simply take 2 pieces of metal and slide them down into the grass so that way when you step on the launch part, the whole thing doesn't jump, because you want to keep your data consistent and you want to make sure you're launching from the same point every time for consistency in your data. Now, let's talk about the clinometer and its role with the rockets kit. So the clinometer kit has 4 different sort of connections. You can use it in a math classroom just as an introductory help for understanding how a protractor works. For that one, you take the simple flat-backed connector piece, slide it right on top of the center circle here, add the arrow, and then slide one of the flexible filament connectors over the top, so that you can then move the arrow around freely. This is very simple, very useful in math classrooms just as a classroom tool. Now, if you're going to do it as an altimeter because you want to see how high your rocket flies, you take a protractor, and this time you're looking for the connection piece with the little arrow pointing down. And you slide that again right over the center, add an arrow, and add the flexible piece. Now, students can look through this side of the altimeter to determine the height the rocket reaches, and the arrow points straight down and tells you the angle. So that's good practice with complementary and supplementary angles too, figuring out what the reading on the protractor looks like compared to what it means for the altitude, for the angle at which it reached its height. You can also build an altimeter using the same 1/2-inch PVC. To do that, you simply take the PVC connection pieces and slide them over the end, and then use rubber bands to secure. Next, insert your protractor once again so that the peg here lines up with the 0 point on the protractor. Then slide the secondary piece in place to hold it steady. Add your arrow and secure using the flexible peg top. And as you can see, the arrow again moves freely, always pointing right down using gravity. So students can look through this to determine the height that the rocket reaches. But this has a dual purpose. So what you can do with this, because it attaches to the same PVC pipe that you're launching your rocket from, is you can actually have this secured to the rocket launcher itself so that you know the angle of launch. The rocket will slide right on the end, so then you would just move this up all the way to where it won't hit the rocket, but it still gives you the option of doing low to the ground angles without getting in the way. Anytime you adjust the position of the protractor, you need to make sure that it stays with the peg at 0 or it will affect your data. Now, the final use case of the clinometer is actually with our gliders kit. So the launcher we have there, again, you simply secure to the meter stick. So this one is when you're launching your gliders to, again, know the angle of launch. So with these kits, the clinometer and the rockets kit, you get a chance to launch a rocket, know exactly what angle you're launching it at. You can use the altimeter feature of the clinometer to know exactly how high the rocket flew. This is helpful in high school when you're figuring out the tangents and you're using trig to determine how high the rocket went. You can use it when you're doing the graphing of the parabolic curves. And in elementary school, it's just a good way to do basic experiments, get the students to start thinking scientifically. And in middle school, it's a great chance for bivariate data and statistical analysis. It's really interdisciplinary fun. I mean, you can't go wrong shooting rockets, right? These do shoot with some power, so make sure that you do everything so that the students have fun and that no one gets hurt. Thanks for listening. Have an awesome day.